All right, so we are looking at chapter 11, section 3. So we're just going to be finding area. So let's just start out with refresher. I know these pictures are not on your paper, but you can do them on your own paper on the back if you printed them. But I just want to quickly review finding area of some basic shapes. So area of a rectangle, so it is length times width. Area of a square is side squared, because remember a square has 4 equal sides. Area of a triangle is base times height divided by 2, where this is your base and this is your height. Area of a right triangle, it's still the same. Area is still base times height divided by 2. But the cool thing about right triangles is the legs are your base and your height. Your area of a circle, pi r squared. The area of a trapezoid is base 1 plus base 2 divided by 2 times your height. So here's your base 1, here's your base 2. Your height is going to be this piece right here. So basically in a trapezoid you can almost divide it into a rectangle into triangles. And then we have the area of a parallelogram, which is base times height, where the base is down here and the height is perpendicular to the base. These pieces right here are not your height, okay? All right, so let's look at a rhombus and a kite. Okay, so a rhombus and a kite have the same formula when it comes to finding area, and it's super easy. You just multiply the diagonals and divide by 2. That's all there is to it, okay? So remember your diagonals are going to be these two pieces here. So in a rhombus, they're perpendicular, and in a kite, they're also perpendicular. So they have that similar property, so that's kind of why they get to use the same formula. So if we're going to find the area of this rhombus, they're telling us that from here to here, so that would be this diagonal here, is 6, and from here to here, so this diagonal is 8. So the area is diagonal 1 times diagonal 2 divided by 2. So 48 divided by 2, so the area is 24 meters squared. Okay, keep in mind though, since this is a right triangle, that they may give you this number and this number, so you would have to do Pythagorean theorem maybe, or maybe they gave you the side. You may have to do Pythagorean theorem sometimes to find the diagonals, so don't forget about that. Over here, we see that this piece of the diagonal is 5 and this piece of the diagonal is 3. So the whole diagonal is 5 plus 3, so the whole diagonal is 8. So area is diagonal 1 times, and then this diagonal is 2 plus 2, so from here to here is 4. So 8 times 4 divided by 2. 8 times 4 is 32 divided by 2. So the area is 16 centimeters squared. Okay, so don't forget these are right triangles, so you may have to do Pythagorean theorem to find a missing piece. Just always remember a squared plus b squared is c squared. Don't forget that if needed. All right, so regular polygons. So this one is new. There's some new terms. What I want you to remember though is the center and the radius of a regular polygon is because there's a circle that goes around the outside. So the center of the polygon is actually the center of the circle, okay? The radius of the polygon is still the radius of the circle. So remember your radius goes to the edge of the circle. So the radius of the polygon is still the radius of the circle. The new word is the apothem. Okay, the apothem is a funny sounding word to me, and it goes from the center and it's perpendicular to the edge of your polygon. So this would be your apothem. So you have to have a radius and an apothem. And then we have a central angle. Remember from chapter 10, the central angle if I were to draw a circle, remember your central angle is at the center. So the central angle of your polygon would be this piece right here. So if you drew 2 radius, the central angle is that angle right there that connects the 2 radius. And the apothem will cut that in half. Okay, so let's just look at some pieces here in an actual picture and name them. So it says in the diagram, WXYZ is a square. It's inscribed, which means it's inside of a circle. They want us to identify the center. Well, the center is here at P. Give a radius. PY is a radius. PX is a radius. So PY or PX. The apothem is this piece here. It's always going to be perpendicular to the side. So PQ. Remember, when you're naming a segment, you have to use 2 letters. And then the central angle is going to be XPY. So angle XPY. So those are your parts. So now we're going to find the measure of each central angle. The central angle is going to be 360 divided by the number of sides. This should look familiar from when we were doing exterior angles before. So for example, the central angle, so if I drew a radius, so radius, go to the corner. Okay, so your central angle is this angle right here. So it's 360 divided by 3 sides. So that means 120 degrees. So this angle right here is 120 degrees. Here, 360 divided by 1, 2, 3, 4, 5, 6. And remember, this only works on regular polygons. So 360 divided by 6 is 60 degrees. So go to the center and draw 2 radius. And this is your central angle. So if I have a regular polygon with 8 sides, that's an octagon. So that's going to be 360 divided by 8. So 360 divided by 8. Well, if I can type the right thing here, divided by 8 is 45 degrees. So the central angle of an octagon is 45 degrees. So in this diagram, we have WXYZ, and it's a square, and it's inscribed. So we're going to find the measure of angle XPY. XPY. So they want us to find this central angle. So the central angle is 360 divided by 4. So that would be 90 degrees. So this is a 90-degree angle inside. And then the measure of XPQ. So let's use a different color here. So XPQ would be this angle right here. Well, that's going to be the central angle divided by 2 because your apothem, PQ, splits the central angle in half. So that's going to be 45 degrees. And then we have angle PXQ. So PXQ. Well, if this angle right here, the red angle, is 45 and this angle is 90, then this angle also has to be 45 degrees because remember, this is a triangle right here and there's still only 180 degrees. So if there's 180 degrees in the triangle, you got a 90-degree angle and a 45-degree angle. There is only 45 degrees left. All right. So now they want us to find the apothem if the sides are 6. All right, so if all the sides are 6, all right, and I will tell you that the apothem right here, it splits this side in half, so these pieces are both 3. So now I'm going to give you a little trick. This only works on hexagons. You can't use it anywhere else, but it's really cool on hexagons, and it'll keep your life a lot easier on these problems. First of all, the radius of a hexagon is the same as a side, okay? So if the side is 6, the radius will also be 6. So if you think about it, you've got this side is 3 and this side is 6. So you can do two things. You can do Pythagorean theorem. So the apothem is the hypotenuse squared minus the side squared. And then you take the square root of that. So the apothem is 36 minus 9. So the apothem is the square root of 27. So the square root of 27 is 5.2. Now, if you remember your 30, 60, 90 rules, so what I'm going to do is redraw that little right triangle for a second. So I know this is 3 and I know this is 6. So remember, if we found the central angle right here, so that would be 360 divided by 6, which would be 60. So the central angle is 60, which means that this angle right here is 30. So that would make this angle right here 30. So this makes a 30, 60, 90. Well, remember, the short side is x, the hypotenuse is 2x, so this side over here is x square root of 3. So that means if x is 3, then this side is 3 square root of 3. Okay? So 3 square root of 3, if you type in the calculator, is 5.2. So either way, you can do your 30, 60, 90s, which are faster, or you can do Pythagorean theorem, whatever's easier, okay? So now they're telling me, given that the apothem is 4, find the radius. Okay, well, this is a square because all of this only works on regular polygons. So if all of these sides are the same, okay, remember what the apothem does is it cuts it in half, right? So if you'll recall just a second ago in this picture here when we had a square, that these two angles were 45, it's going to be that way on every square, okay? So that means that this is 45 degrees and this is 45 degrees. So this is a 45, 45, 90, which means if this is 4, then this piece right here is also 4. So if this is 4 and this is 4, remember the rules. This side is x, this side is x, then this side is x square root of 2. So my radius is 4 square root of 2. Okay? In a triangle, given that the apothem is the square root of 3, so this is the square root of 3. Well, in a triangle, if you recall, this problem right here, oops, back up one more. Well, I went too far that time. Where did we do the one? Was it at the top? This one, that the central angle in a triangle was 120. So if I go down here, if I were to draw this other radius through here, this whole central angle would be 120, so that means this is 60. Okay, so you're really going to have to use those 30, 60, 90, and 45, 45, 90 rules that we did before spring break. So if this is 60, then this is 30. So we label the triangle according to 30, 60, 90s. This is x, this is 2x, because the hypotenuse is always double. This is x square root of 3. So that means that x is equal to the square root of 3. So 2x is equal to 2 square root of 3, because we're just going to replace x with what x is actually equal to. Then we have x square root of 3. Well, if x is the square root of 3, and then we have a square root of 3, the square root of 3 times the square root of 3 is 3. So that means that this side is 3. So it says find the perimeter, okay? Well, if this piece right here is 3, then this piece right here is also 3. So that means the whole side is 6. So if all the sides are 6, then the perimeter is 3 times 6. So my perimeter is 18. And that would be the answer to that one. So depending on what it's asking you to find, you're really going to use these 30, 60, 90, and 45, 45, 90 rules a lot, which is why I was stressing to make sure you understood how to use your 30, 60, 90 rules. All right, so now we're going to find the area using the apothem, the perimeter. The formula is 1/2 AP. Okay, so this is how I do it. The area is the perimeter times the apothem divided by 2. These are the same formulas. I just write it like this because to me it's easier. So they're telling me that the radius of this square is 5 square root of 2. So since this is a square, automatically these two are the same. That's always, okay? So if this is a 45, 45, 90, this is x, this is x, this is x square root of 2, so that means x is 5. So this is 5, and this is 5. So my apothem is 5. The radius was given, 5 square root of 2. Now, if this piece is 5, then this piece is also 5. So that means the whole side is 10. So that means the perimeter is 4 sides times 10 each, so 40. So my perimeter is 40. The area is the perimeter times the apothem divided by 2. So 40 times 5 is 200. Half of 200 is 100. Okay, so yes, could you have done 10 times 10? Absolutely, because 10 squared is 100. So you could have also done the area that way. And to be honest, I would do the area like this. I would do it the easy way. But you have to know how to get this piece here by using this triangle. Okay, so same thing here. So just so we can practice, the apothem is the square root of 3. So the apothem is the square root of 3. So remember, this piece, and this piece are all the same. And this is every square, okay? So if this is square root of 3 and this is square root of 3, then that means the whole side is 2 square root of 3. So that means the perimeter is 4 sides. Each side is 2 square root of 3. So the perimeter is 8 square root of 3. So I'm going to go down here and I'm going to say, okay, the perimeter is 8 square root of 3. The apothem is the square root of 3. So the radius is going to be square root of 3 times the square root of 2. So that makes it the square root of 6. Because remember, x, square root 2. So the area is perimeter times the apothem divided by 2. So remember, the square root of 3 times the square root of 3 is just 3. So 8 times 3 is 24. 24 divided by 2 is 12. And this would be inches squared because they gave me it in inches, and I should have did this over here. This would be centimeters squared. So 12 inches squared. Okay, so this is how you're going to use the formula when you're finding the area of a square. You're still more than welcome to use side squared if you know how to get this side. Okay, so you are going to have to work with this to get the side so that you can use this formula, or you can use this formula. Either way is correct. So now we're going to look at an equilateral triangle. This works every single time. Okay, it says the side of an equilateral triangle is 8. So if the side is 8, then that means this piece is 4, because the apothem will always cut it in half. First thing I'm going to do, the perimeter, 3 sides at 8 each. So the perimeter is 24. So I'm going to go down here and I'm going to put the perimeter as 24. Now, every single time, no matter what, your central angle, okay, will always be 120. So this angle right here will always be 60, and this is 30. Okay, that will never change. So this works every time we have an equilateral triangle. So what I do know is that this is x, this is 2x, and this side is x square root of 3. So I need to know x because x is my apothem. Okay, x is the apothem. So if x square root of 3 is equal to 4, then I need to divide by the square root of 3. So I'm just going to type it in my calculator. It's going to be a decimal. It's going to be fine. 4 divided by the square root of 3 is 2.3. So my apothem is 2.3. The area is the perimeter times the apothem divided by 2. So 24 times 2.3 divided by 2 is 27.6. And they gave this to me in centimeters, so this is centimeters squared. Okay, so every single time you have an equilateral triangle, this angle will be 60, this will be 30, every time. So your apothem will always be labeled X. Now we have a regular hexagon. So I'm going to draw a hexagon. I know I'm cheating. So do the best you can on your paper. So I'm going to find the center and I'm going to draw an apothem and I'm going to draw a radius. You have to be able to draw these things, guys, okay? This angle here is always 30. And this angle here is always 60. So it's just backwards from an equilateral triangle. This one is 60, this is 30, and a hexagon is the other way around, okay? So now I know that the radius is the same as my sides. So all the sides and the radius are all the same. It says the apothem is 10, so this piece is 10. So what I'm going to do is I need to find the length of the radius so that I know the side, so I can find the perimeter. Okay, so using our 30, 60, 90 rules, so this is x, this is 2x, this is x square root of 3. So what I know is that x square root of 3 is equal to 10, so divide by the square root of 3. And let's get our decimal. So 10 divided by the square root of 3 is 5.8. So that means that this side is 5.8. Well, if you double that, so 5.8 times 2 is 11.6. So that means this is 11.6. So my perimeter is 6 sides at 11.6 each. So 11.6 times 6, so 69.6. So the perimeter is 69.6. All right. So it says to find the radius. Well, the radius is the same as the sides. So the radius is 5.8. The length of one side. So one of my sides is 11.6. And then find the area. Area is perimeter times apothem divided by 2. So 69.6 times 10 divided by 2 is 348. So the area is 348, and they gave this to me in units, so this is units squared. And I don't know what happened to that, but that's units squared. All right. These take a little bit of practice, but if you just use the rules, you will be okay. It says find the area of each composite. So a composite is 2 or more figures. So if you look, we have an hexagon and a trapezoid. And there's a lot going on in this picture. But what I do know is that the area of this one is PA over 2. Okay, so I know that this piece right here, because they're telling me from here to here, is 0.8. and they're telling me that the radius is 1.6. So that means the sides are 1.6. Always look at what's given because they may actually give you something that you didn't know. So 1.6 times 6. So the perimeter, 6 sides at 1.6 each, is 9.6. So if I know this, then I can find the apothem because I need the apothem. So if I did Pythagorean theorem, because I know these two sides, so the apothem is the radius squared minus half the side squared. Take the square root. So 1.6 squared minus 0.8 squared. Take the square root. It's 1.4. So the apothem is 1.4. All right. So the area of the of the hexagon is perimeter times apothem divided by 2. So 9.6 times 1.4 divided by 2 is 6.72. Now the trapezoid, so here is, I'm going to put an H here for hexagon, and then I will do this. So the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So here is base 1 plus base 2, which is 2, divided by 2, times the height. The height is always perpendicular, so 1.5. I'm going to write over that number there. So 1 plus 2 is 3. 3 divided by 2 is 1.5. So 1.5 times 1.5. So this piece is 1.5, and then your height is 1.5. So that's 2.25. So the area, here is 2.25. So now it says hundredths, so we're going to leave the 2 hundredths there. We're just going to add those two numbers together, and then that's your total area. So 6.72 plus 2.25. 6.72 plus 2.25 is 8.97. So 8.97 inches squared. So there is the hexagon plus the trapezoid. Now over here, we've got this triangle. Okay, so we're going to find the area of the triangle. So the area of the triangle is base times height divided by 2. Well, they're telling me from here to here is 7. So the base is 7 times the height is 4 divided by 2. So 7 times 4 is 28. Half of 28 is 14. So the area of the triangle is 14. Now the area of this is a sector. Remember, this is the slice of pizza. So this is from chapter 10. So we're going to have to do the proportions. So 60 over 360 is the sector over pi r squared. And this is going to be your radius. So we're just going to cross multiply here. So 60 times 49 pi, because 7 squared is 49. And then we're going to divide by 360. So 25.66. So the area of the sector is 25.66. And I'm going to do a little squiggly to keep these two problems separate. All right, so now we're going to get the total area is 25.66 plus 14. So 39.66. and that is centimeters squared. All right. My little lines are way off tonight. All right, so now we have our last figure. So what I see when I look at this is I see a parallelogram and a kite. So I'm going to find the area of the kite. I know this diagonal is 7 and this diagonal is 6. Diagonal 1 times diagonal 2 divided by 2. So the area of the kite, 42 divided by 2 is 21. This is a parallelogram. So base times height. The base of my parallelogram is 4. The height is always going to go straight up and down, which is 3 in this case, because they didn't tell me the side lengths. They're telling you the straight up and down. So 4 times 3 is 12. So add those two numbers together. So the total area is 21 plus 12, which is 33. So the area is 33 feet squared. Okay. All right, so I'm going to do one more with you just to make sure. I want to make sure you understand. What if you have a pentagon? Okay, because the pentagon doesn't use 30, 60, 90 rules. It's going to be easier, okay? So if I were to draw the apothem and draw the radius, okay? It doesn't use the hexagon rules, okay? So if you think about, for just a second, I'm going to draw an extra radius in here. I'm going to make it dotted because we're not really going to use it a whole lot. All right, so remember that the central angle is 360 divided by the number of sides, okay? So 360 divided by the number of sides, which is 72. So this whole angle is 72, which means this angle is half of that. So 72 divided by 2 is 36. So we're going to have to use trig on these, okay? So if I told you that this was, I don't know, let's just go with 10, okay? So if the radius is 10, which would be the hypotenuse of this triangle, I need you to find the apothem. So if this is the hypotenuse and this is adjacent to this angle, then that's cosine, okay? So if we go back to this little rule here, so the cosine of 36 is adjacent over hypotenuse. So remember, when this is in the top, all you do is cross multiply these two. So the apothem is, so 10 cosine 36, 10 cosine 36 is 8.09. So the apothem is 8.09. So now I can also find this piece because I need this to get this so that I can find the perimeter, okay? So this is opposite. So if I did the sine of 36 is opposite over hypotenuse, then I would cross multiply these and I would get that the opposite side, so 10 sine 36 is 5.88. So this piece is 5.88, which means this piece is 5.88. So 5.88 times 2, so that makes the sides 11.76. So the perimeter is 5 times 11.76, which is 58.8. So you're going to use your perimeter and your apothem. Area is perimeter times apothem divided by 2. So as long as you remember your trig from chapter 9, then these are pretty easy because you're just going to cross multiply. So 58.8 times 8.09 divided by 2. So the area is 237.85. And I'm going to say units squared because I didn't specify whether it was inches or whatever. So that's how you're going to do everything other than a hexagon, a triangle, and a square. If you have a hexagon, a triangle, and a square, you're going to use 45, 45, 90 or 30, 60, 90 rules. If you have any other figure, you're going to use trig. Okay, so you're going to have to use your trig rules. Okay, so make sure you let me know if you need help. Okay, and I will definitely answer questions for you. See y'all later.